But Craig has actually been working with Ametalin and designing building membranes over the last 17 years to provide technical support and guidance to the industry and customers. And during that time, he's of course learned from the ground up what it takes to develop, produce, and deliver the best building fabrics to the building sector. Very much accomplished, proficient, and in tune with holistic knowledge of the National Construction Code, NCC, Australian standards, testing compliance requirements. Craig strives to excel at delivering high-performance, compliant products to the market through Ametalin, and always motivated to troubleshoot and provide technical support and guidance to industry and customers. And we're really appreciative for Craig to be with us because as we talked about various low embodied energy materials, as Scott has rightly pointed out, and also James, we need to make sure that the design is correct and in the detail and what kind of products you use to help making sure that there's good breathability and vapor management. So Craig is with us to go over that. So please welcome Craig.
Hi everyone. Thank you. My name's Craig Lumsden. We're going to cover building breathability, vapour management, outlining how to manage moisture and vapour through product selection and some construction details. Put in a little disclaimer, of course. This is just essentially to encourage you to contact us. for any specific building design you have, etc. We'll touch broadly on the following: building fabrics, the building envelope, vapour drive, climate zones, and some vapour management, leading us to some rules of thumb for guidance on vapour management in Australian buildings and considering approaches to choosing building fabrics. What we like to describe as building fabrics. So building fabrics can take any form, not just membranes. So there's bricks, mortar, cladding, fibre cement, glass, insulation, and of course pliable building membranes. So each building element has a different resistance to water vapour transmission. So this is its ability to capture, transmit, release. Stuff like brickwork can hold up to 1 tonne of water in a house. And it can do that without too much drama. So the brick naturally loses moisture and it gains moisture. So it's very dynamic. If there's too much around, it'll actually hold on to it. Let's think about how condensation forms. Okay, the warmer the air, the better the ability it has to hold vapour. So as the air is increasing, so can its ability to hold water. Condensation will always form on the warm side of a building fabric. So if we think about vapour and condensation in relation to the building envelope, we have the fact that there's naturally a difference between internal and external. This difference between warm and cold areas, inside and outside, then creates drive. So we have vapour drive. Also, the direction of vapour drive can even vary between walls of the same house. So depending on the orientation, exposure. I think we all know that, there's a lot of vapour sources inside a home. Cooking and dishwashing, laundry, showers, baths, indoor plants, if you like indoor plants. An indoor plant will add 800 mil a day, just one plant. So, person's exercising, and even gas appliances. So it all adds up. But the major nocturnal load in winter, of course, is from occupants sleeping and breathing. The other loads in comparison to this are actually relatively minor. So, for example, with a ventilation rate of one air change per hour, the other moisture loads, such as cooking and washing, will almost be completely dissipated by the time the actual greatest condensation risk occurs, just before dawn, because you're in there sleeping. That family of four is expected to release 10 to 14 kilos of water vapour in that 24-hour period. This, coupled with declining ventilation rates, puts a much greater demand on the building design and the fabric to alleviate this risk. Water vapour, it moves from regions of high vapour pressure into regions of low vapour pressure. So always moves from warm to cold. So on the left there, we have sort of Darwin, warm outside. Inside you're trying to stay cool, so your vapour drive is inward. Best way to combat this is a vapour barrier on the outside of your walls or roofs, and even closing between the roof and the wall, even closing off those gaps. So if you can get a complete seal on the outside, up in your wet tropics, it's the best chance you've got. Conversely, the opposite is for the cold regions, which is on the right, and you're creating all of that vapour, and all it wants to do is get out. If you inhibit this drive at all, then you're going to get places where interstitial condensation occurs. Modern housing now, with higher insulation levels, more and more sealing, caulking, etc., and less ventilation, improves the all-round energy efficiency of the house. In ABCB climate zones 6, 7 and 8, the unintended consequence is the winter build-up of moisture in the internal air. This causes vapour drive through the walls towards the cold exterior. If an impermeable wall wrap is installed on the outside of the insulation with a cold surface, it will be a cold surface, inhibit transfer and condense water. So vapour permeable construction materials and fabrics ensure that this trapped vapour can escape without condensing into a liquid, or if it does, allows it to release it sooner rather than later. So this prevents moisture build-up internally. Tools that can help to determine and identify risks in your building system, hygrothermal or WUFI, and these help calculate your risk which may form in your building system. Rule of thumb is choosing the most extreme season of risk, I suppose, and as well as the most extreme differences in the temperature conditions. You can notably determine a worst case scenario and then plan your design for most extreme levels of risk. Also, you may need to assess the drying out cycles as well, and then they can work together. Adapt an approach and work with the system. How do we control water vapour with membranes? So we have vapour control, vapour barrier versus vapour permeable, water control, water barrier versus non-water barrier, air control, air tightness for energy efficiency, and thermal control. combination of these properties work together to suit different applications, types and performance requirements. So a good membrane for cooler climates would be airtight, water barrier and vapour permeable. The requirements for these areas are in figures about 700 mil to 1.5 litres per day as the ability to release. Ventilation and air changes, okay. Air cavities. Now the beauty of an air cavity is can provide a physical break in the vapour drive, and they're a vehicle for ventilation and drainage. Air cavities work naturally to relieve the system of moisture build-up, and they're an efficient air barrier and dry out faster. Opportunity for added thermal performance. Air cavities and ventilation are beneficial in a wall, but also in roof constructions. So, especially in colder climates during winter, interstitial moisture can build up and easily condensate under the metal deck. And where possible, feature air cavities and a ventilated design. So before designing, where is your site located? Wet tropics, vapour drive inward, summer moisture risk. Subtropical, vapour drive variable, summer and winter, principally south, the Tropic of Capricorn. Temperate coastal, vapour drive variable, predominantly outward, mostly winter moisture risk. And then we get down to cold zones, vapour drive outward. Semi-arid interior, not a lot of risk there. Okay, so these are some different systems for different zones. So taking all of these considerations together, we can adopt an integrated design approach. Design to build your climate zone, building system for extra thermal comfort, moisture management and energy efficiency, building towards net zero ready and high performance homes.
Thank you very much for going through all the detail on that, especially because I think a lot of the science of why we're actually trying to make sure that we are implementing good moisture control, moisture and vapor control, and how that links in with the health and well-being of the occupants is something that gets missed a lot, and it's sort of like the devil's in the detail sometimes of like where you put it, and like you said, depending on where the project is actually located, it will actually vary across. So thank you very much for highlighting all those different aspects for us there.